Hey everyone, welcome back to CyberBee. This is the channel where I share what I learn in cybersecurity as I go. And today we are jumping back into Let's Defend. We are on the SOC Analyst Learning Path here. We've completed four courses and now we're going to the fifth one, which is Detecting Web Attacks. Now I did do a couple of them without filming, my bad, but I will go back and we will do this together, okay? So we're going to go to Introduction. And basically what this part says is, 70% of all attacks, what was it? The stat, sorry. A study done by Acunetics found that 70% of all cyber attacks were at the web application level. So these are things like Google, Facebook, YouTube, they're all web applications. And so some attacks could be SQL injection, cross-site scripting, command injection, IDOR, I don't know what that is. Okay, insecure direct object reference. Sounds like it's programming related. RFI and LFI, I don't know what those are either. Okay, good. We'll be learning a lot of stuff today. And web upload with file upload on a web shell. Okay, cool. So that's what we're going to be learning about in this course. Next. Okay, that doesn't look like it gives me too much information. So next. Okay, OWASP. OWASP is Open Web Application Security Project. It is a nonprofit organization dedicated to improving software security. And so one of the kind of like most cited resources in industry would be the OWASP Top 10. So every 3 to 4 years or so, they come up with a top 10 web application vulnerability list that, people like us should be looking out for. And so they had one in 2017, they have one in 2021, which is the latest one, and I was just on the website, and it says for top 10 2025, as of September 2024, they're still kind of collecting information and whatnot, and so it's not going to come out until the first half of 2025. So from now until June, that's when we can expect it. That's a huge gap, by the way. So right now we're just going to refer back to the one that the latest one, which is 2021. So let's just read out a couple of these ones. So the list has number 1 was broken access control. 2 is cryptographic failures. 3 is injection. Then insecure design, security misconfiguration, vulnerability and outdated components, identification and authentication failures, software and data integrity failures, security logging and monitoring failures, server-side request forgery. Okay, there's a lot of failures happening. There's like 4 of them. And it kind of sounds like people are not patching or updating as they should. And yeah, and probably misconfiguring some things. Anywho, okay, so there's some questions here. So this really does require us to go outside of Let's Defend to do our research ourselves in order to answer these questions. And so first question, what is the name of the tool that OWASP has prepared to help scan web applications for vulnerabilities? So I found this answer, I think I was just Googling it. Yeah, I think I was just Googling it and I found it. But essentially, let's look at that. OWASP Zap. Yeah, tutorial. That's what I would do. Dun, dun, dun. Sorry, I do not have paid YouTube.
Keeps you on track. Hard drive. Try. Welcome to the tutorial on OWASP Zap. That means it can be installed on Windows and Linux. It's only use Zap. Any messages use and pages. But it can still performs a variety of attacks on the application.
Okay, hold on. There you go. You're installing. Okay, let's just jump to one of these.
In this video, we will see how probably see the proxy, which is at the bottom in the footer bar. So what we need to do is go to the tools option, click on the options, and scroll down to local proxies. Here you can see the local proxy setup as we have done the setup in Zap. We specified in Zap was 8081. And make sure you just click on and close this tab. Click on Find New Session, so it will discard all the details here, so it will start with fresh. So let's see how to do it in the Internet Explorer. So if I just double click on Internet Explorer application, so if I just...
Okay, so I kind of get an idea of what I'm looking at here. Okay, let's go back to this. So name is Zap. Okay, second question, which area does OWASP focus on? Web applications, A, B, server management, or C, wireless security. So it's just set up there that it is top 10 web application vulnerabilities. And so A is the answer. And third question. Well, I'll show you in a little bit. But I was going to tell you the formatting of the answer. It actually tells you in like grayed out text what it's looking for. So you're not typing out web applications. They're just looking for like one single character. Okay, next one. What is the name of the vulnerable web application project that OWASP wrote using Node.js JavaScript for security researchers to improve themselves? Okay, this one was a headache for me to find. It just didn't come up anywhere I went. So for example, go to Google and it would tell me it was like Node Goat, which is not the right answer. And everywhere I looked, I didn't find it until I stumbled upon Li Xing Zhang's Medium blog. And it was right here. Juice Shop. Let's take a look at that though. Okay, go away. It's probably the most modern, sophisticated, insecure web application. Can be used in security training, awareness demos, capture the flags, and as a guinea pig for security tools. Juice Shop. It's kind of hard to say. Juice Shop encompasses vulnerabilities from the entire top 10. Okay, along with many other security flaws found in real-world applications. All right, it's a flagship project. Contributors licensing is free, open source. That's really cool. I will download this and take a look at it next time. Okay, what does the OWASP top 10 list published every year reveals? A, most critical security risks to mobile application. No, most critical security risks to web applications. That is the answer because it's similar to question 2. Most encountered web application vulnerabilities, most encountered mobile application vulnerabilities. So I guess really the difference is between, well, we know it's about web applications. So here we're just picking, is it most critical or most encountered? And it's most critical because that is the definition that they had given us at the top. Okay, so got that? Good. Next. So I haven't started this yet. So we are going to do this at the same time. So how web applications work. To identify, okay, you know what? Let me pause so I'm not just like reading things out to you, and then I'll come back and summarize what I found, okay? Okay, so this lesson here is a little bit long, so let me try to summarize this for you. So how web applications work. Essentially, we're talking about HTTP protocol and how that works. So HTTP protocol is on layer 7 of the OSI model. So just quick refresher, there's a TCP IP model, which is 4 layers: application, transport, network, and network interface. And then there's OSI model, which is kind of like the standard one that everybody uses these days. So if you've been studying for Sec Plus or any of the other, blue team defense type certification, you probably needed to learn a bit about networking, which is what this is. If you'd like, because I'm not going to be explaining this in a very deep level right now, a recommended YouTube video on like just an explanation of each layer and what it does and how it all works together, let me know in the comments below and I can link that for you. It's the video that I used when I was studying for Sec Plus. And on a side note, I have a really good video to recommend as well. Leave a comment below if you want that on port numbers and what they correspond to. Before I was just trying to like memorize it. This number means this, but it was almost impossible until I watched this video. And this guy just made it really relatable and easy to remember. So yeah, let me know in the video. Let me know in the comments. So yes, let me know in the comments. Okay, so HTTP is application layer, application presentation and session in the OSI model. We won't need to cover this, I don't think. So we're just focusing at the top part here, okay? That's layer 7. So it starts here, right? Physical is 1 and it goes all the way to application, which is 7. And yeah, this one as well. So I was going through it a little bit backwards, but if you know, you know. Okay, so essentially what happens is your computer sends a request to the server. Server then comes back with a response. So that's kind of how HTTP protocol works at a very simple, basic level. Okay, so this now goes into detail about what it looks like, what these HTTP requests looks like. So it gets HTTP 1.1, and then there's a whole bunch of different stuff right now that I may or may not So essentially, HTTP requests is from the device to the web server trying to retrieve a specific resource. So I want to go to this particular web page, let's just say, right? And this is what it sends. This is what it looks like on the back end. Like us humans, we don't see this, right? This is what computers get when they talk to each other. And it actually does explain every single one, what each line means, which is great. I'm not going to go through that with us right now because we're trying to go through this whole entire course today. HTTP responses is once the server gets that response, what it sends back to that endpoint. So HTTP 1.1, 200 means okay. These are just like status codes, which we'll cover in a little bit. And it tells you the date. The connection is now closed. Server, this is what it's using. Last modified on this date. Content type, it's text on HTML. And content length. Interesting. So 170 characters? That's so specific. Like it's such a tiny detail to include. And there you go. If you know how to read HTML, then you'll kind of know what this says, right? Response body. Okay, cool. Next, we're going to talk about status lines. Okay, so interesting. Okay, 100 to 199 is informational responses. Anything in the 200 is success, so like okay. Anything in 300 is redirection messages, and 400 is client error, 500 is server error. Okay, this you also kind of cover in Sec Plus. Either that or I kind of knew it already. So let me just show you what it means. So for example, I'm sending using my browser or my device to send to the server. I want to go to this URL, right? And it goes to a 404 because it's not found. Not found means there isn't actually a page that exists on the OWASP.org website. So that's what it's showing. This one, the client error. So client, the client device. Yeah, that's what they call it. Client and server. Okay. Yep. And then it also tells me in here what all those mean. That's great that it breaks it down. And there, going to questions. So I only half answered this so that we can do it together. So question 1, what layer is HTTP on in the OSI model? So it's application. So this is what I mean by answer format. This is exactly what they're looking for. So word like underscore word, right? Which HTTP request header contains browser and operating system information? Okay, so I'm going to have to go back up here. Contains browser and operating system info. Let's see. Browser and operating system info. This thing? Let's see. Here's the explanation. Version of the web server. Yeah, caching. Content type. Okay. Was it this thing? Maybe not. But it's like, Oh, sorry. I'm looking at the wrong thing. It says request. That's why I'm like, oh, it's not making sense. Okay. It's user agent, I believe, because it's asking for operating system, right? And browser, is that what it said? Let's try user agent. User agent. Yes, got it. Next question. What is the HTTP response status code that indicates the request was successful? 200. Got that. Let's answer this last one too before we go to this one to work together. Which HTTP request header contains session tokens? The answer is cookie. I thought it was cookies, and then it told me that I was very close, and then I deleted the S, and then I got it right. So I'm not sure actually if they covered this there, but I knew that off the top of my head because, yeah, how did I know that? I knew that before studying Sec Plus. It was just something that, I don't know, I had in my mind. But I'm sure it told us up there because they have so much text. Which HTTP request method, okay, ensures that the submitted parameters do not appear in the request URL? Oh, that's getting a bit complicated. Okay, answer format, one word, and it's like 4 letters, if I'm reading this correctly. HTTP request method ensures that the submitted parameters do not appear in the request URL. Okay, so going to request, not respond, and it's asking for a specific method. Okay, let's see. The get method indicates that the resource is being requested from them because there's no name being requested. Okay, so it has the word method here. Okay, there's also this one. Any other post permits can be bound. Any other data to be sent. What is 11? Oh, I see. Well, I don't think it's that. Should we try get? Wrong answer. Get. Nope. Okay. Let's see. Okay, found the answer. It is post. I just wanted to point out that here is number 3. For that question that talks about the answer was cookie, you can find it here. And I tried another answer. It didn't work. And then it kind of turned to this. You can ask for help with this question in the community. Ask now. Let's see what that looks like because I haven't done that. But the answer is post. Okay. Oh, it's a Discord. I have not joined it yet. I should. Okay, next. Detecting SQL injection attacks. Okay, so what is SQL injection or SQLi? Tiny I. Okay. There are critical attack vectors in which a web application directly includes unsanitized user-provided data in SQL queries. Yes. So basically what this means is, you kind of get access to like a thing that you can type in, like an entry like this. Let me find you an actual example. Hold on. Okay, now we are at the next one, detecting SQL injection attacks. Just wanted to show you what their Discord looks like. So just wanted to show you what their Discord channel looks like. It's welcomes and rules. Okay, note resources, announcements. That's cool, and they're like, they're active. They just posted yesterday. Text channels, questions, feedback, feature requests, off-topic journal memes, job postings. It's always cool to look at. Okay, just 2. Okay, back to this. Detecting SQL injection attacks. So what is SQL Tiny I? It is when unsanitized user-provided data in SQL queries creates havoc. Okay, this is a really long lesson, so let me read first and then summarize. Okay, so SQL, structured query language, is usually used with databases, right? Something that we know. There's 3 types of injections. In-band, this is classic. Okay, this is the one that's easiest to exploit by attackers. It's where the query is sent in and responded to on the same channel. This is called in-band. Inferential is when the response cannot be seen, so also called blind, SQLi. Out of band is when the response is communicated through another channel. Okay, so how does it work? Most standard web apps receive data from a user and use that data to display specific content. The login page is where most SQL injection attacks occur. True. Okay, a user is usually expected to enter their username and password on the login page. Then on the other side, the web app will use this information to create a SQL query like the one below. Select asterisk from users where username equals to username and password equals to user underscore password. Yep. The meaning of this query is like, bring me all the information about the user from the users table whose name is username and whose password is user password. So when they find a matching user, it authenticates the user. If it cannot find a user, then the login will fail. Yeah. Okay. So let's just say this is your login, John, and then your password is super secret password. So when you click on login, it then goes to authenticate you, and then you can log into whatever thing that you're trying to get, right? Trying to log into. However, what happens in an SQL, because this is directly linked to the database, is in the password, likely, I think, they start putting in random commands. And if the database actually actions on those commands, it can give that person way more information than they need. I would be pleased to get an error message. Okay, hold on. Yes, definitely during SEC class we learned that if you show an error message, that could be giving the attacker more information than they need to attack you even more, to breach even more. Yeah, this, or 101, sorry, or 1 equals 1, like with the quote, that's a very common SQL injection. Like when you see this on any logs and stuff like that, you know that that's what they're trying to do. It's like SQL injection. And password. Username equals to quote unquote, or 1 equals 1. So 1 equals 1 is a true statement. So it doesn't matter if the username field is empty or not, because 1 is always equals to 1. Yep, this query will always be true and most likely call the first entry in the database. And then the attacker will successfully enter the web app because there is a match. There we go. They explain it way better than I do. Okay. So, okay, I think I'm just going to go through this whole entire course with you just to make sure that we're all on the same page. So to understand why attackers do SQL injections, so this is what they get. They can authenticate, they can bypass authentication, they can command execution, they can infiltrate sensitive data, create, delete, and update database entries. Okay. So, I mean, that's a lot of stuff, especially since, say, they're probably targeting financial databases, you know, somebody's organization's customer database where they store people's credit card information or their address or, you know, like other things that they shouldn't have access to. So that's kind of the incentive for them. So how to prevent SQL injection? Okay, use a framework. Keep your frameworks up to date. Okay, always sanitize the data received from a user. Avoid the use of raw SQL queries. Okay, so basically sanitization, data sanitization, what this means is you want to sanitize everything, it says, headers and users, not just form data. So basically, when you go in here, log in, and then when you go to password, if you're entering certain characters in there that shouldn't be, it should check first. The system itself should check first to see that, you know, these characters that shouldn't be there is there, and then not give you access, like stop you from proceeding further. So for example, the login, say, shouldn't have a space and you did put a space in it. Well, it's not recognized, sorry, right? Same with password. Maybe, I don't know, it's always telling us to use special characters nowadays. Just trying to see. Oh, maybe you're typing in, I don't know, some other language other than English. Like it should know that and stop you from proceeding. Things like that. That's data sanitization. I don't know who uses raw SQL queries anymore. I feel like that's a very outdated practice. But I could be wrong. There's a lot of legacy, systems, so maybe people are doing dinosaur things like that too. Okay, detecting SQL injection attacks. All right. How do we detect it? So you want to examine web requests, check all areas that come from your user. Look for SQL keywords, so insert, select, and where. Check any special characters, like apostrophe, dashes, parentheses. Familiarize yourself with commonly used SQL injection payloads. You can find some commonly used one here. Let's take a look at that. Oh, GitHub. Here's a laundry list of these payloads. There's scanners to use. There's scanners for everything nowadays, I think. Injection payloads. There we go. All these like little things. That's quite a lot. Wow. Okay, generic error-based payloads. Yeah. Having or and as inject X where 1 equals 1 and 1 equals 0 dash dash. I haven't seen these before. I only know about the 1 equals 1 or something like that, some other true statement. Much more than I thought. Okay, let's go back to this. So detecting automated SQL injection tools. Look at user agent. Check the frequency of requests, right? If they're like seconds back to back, seconds apart or back to back. Look at the content of the payload. Yep, if you see this SQL map or 1 equals 1. If payload is complicated. Okay. A detection example. We have access logs of a web application that was the victim of a SQL injection attack. You may not know what an access log is. In a nutshell, they are the access logs from a web server. These logs usually contain the source IP, date, requested URL, HTTP method, user agent, and HTTP resource response code. They're very useful for investigations. Correct. Okay. First of all, we look at the pages that were requested. We see that besides pages like info.php, which is quite readable. Okay, let's talk about the percentage symbol. Yeah, this looks familiar. Right, okay. So percentage 20 equals to the space character. Percentage 21 is exclamation mark. Okay. I also had to look over this for Security Plus. Why are we talking about this right now? Because these are special characters that could be put into requests. Anything with a percentage symbol above are pages that contain special characters. Okay, so basically we're trying to spot this, right? We're trying to spot this in the access logs because that can be a signal that something is up, so that we should investigate it a little bit more thoroughly. Because a space should just be a space, not a percentage 20. Okay, it's a lot of text. So far we covered there is an SQL injection attack on the ID perimeter of the main page. The request came from IP this. There were more than 50 requests per second. This attack was carried out by an automated vulnerability scanning tool. The complex nature of the payload supports the assertion in number 3. We cannot determine if this response was successful or not, as we have no information on the size of the response. Interesting. Okay, there's also a Let's Defend lab that we should connect to. So I'm just gonna click on that. Okay, hold on. And we need to do this lab in order to answer these questions. These 4 questions. Okay, so use the root desktop question file SQL injection web attack.r file. File password is access. So what date did the exploitation phase of SQL injection attack start? Okay, so we're looking at question file SQL injection web attacks. Come on, go up. Question file. That's not what I asked for. Question file SQL injection web. Open this. Oops. Massive. Okay, what was that first question? What date did the exploitation phase did it start? What date did it start? Oh, why is there so much of this stuff? Okay, it includes the time. Okay, gotcha. All right, well, let's look at that. Make this, oops, make this big. This is the SQL injection, Apache access log. Okay, let's see. It's like bigger than my screen. Maybe I shouldn't make it huge. Okay. This is 207 entries. Okay, so it's probably this. Copy. I ran into this thing last time I was in the lab where I couldn't actually copy and paste. Yeah, see. Doesn't do that. Okay, so let's see. I am taking a picture right now from my phone. My screen is not bright enough for me to see anything. Okay. Okay. For me to manually punch this in. Okay, so it's 24 Feb 2022, 11:44, 32 seconds. Let's see. Wrong. Why is it wrong? Did I punch that in wrong? Is it because I didn't capitalize that? You have already sent this answer. Okay, you're smart. I get it. All right, so basically, this is not when it started, is what it's telling me. Get favicon 44200 200. Is it just getting the same thing over and over and over again? What is happening? Okay, so we're in the lab environment. I opened up the file that it's telling us to look at, which is this one. It's on the desktop, question files, SQL injection web attacker.r. And then the file password is access. And the first question is, what date did the exploitation phase of SQL injection attack start? And I was able to find out as March 1st, 2022, 08:35, 14 seconds. So, it's actually quite far down into the logs. It's like line, 140 something. There's only 200. There's only 200 like log entries. And so what I did was I tried searching for, where'd it go? That's why you see it. There you go. I started searching for things that we learned was like a sure sign of SQL injection. So 1 = 1, nothing showed up. Oh, come on. Or some stuff showed up, but it didn't really, it looked legit kind of. Like it wasn't really that 1 or 1 = 1 type of a thing. There's only 5 and it was these 5. I thought, okay, maybe I'm being too specific, and I hit enter sign. And right away it shows me this ID equals 1. And we had learned from our readings prior in this lesson that that is one of the signs to look for. And it says, and submit equals submit, which is, it's like a true statement, right? So it's the same thing as 1 equals 1, 2 equals 2, 3 equals 3, dog equals dog, whatever. So there's that. And okay, so the reason, so it's this, March 1st, 2022. 0835. So there's a series of these that we see. It goes all the way down to 08. So basically 8 a.m. 40 minutes and 26 seconds. So the right answer was this one. And let's see why that was the right answer. I'm not actually sure myself. I like entered these a couple of times because I thought it was this one, the 01. So it goes 200 SQLi. Oh, it's right there. What? That's so funny. SQLi. And there's like 44 of these. That's crazy. But this was the first one. This was the first one? 08. Yeah, here. This was the one that they wanted. Okay, question mark ID equals, and you can see here, oh, okay. I mean, I guess the difference between the first two here, like they all say SQL, right? The first two was question mark ID equals 1 and submit equals to submit. They did that the second time. And then this one is question mark ID equals to percentage 27 and submit equals to submit. And we know that one of these percentage plus number is the kind of special character encoding. So that is also a sign of SQL. The next one also has that too. This one is 1% 3D 1. Okay. Well, I'm not sure why it's that one and not the other ones. Let's read into it a little bit more. 200, they all got 200. Status code 607. I think that's the time it took for the server to come back to them. And it goes to this, URL. That's the IP URL. Submit equals submit. ID equals 2. I'm not sure what makes this one different than all the other ones. I'm going to have to come back to that. And how I would do it is they'll probably copy and paste a couple of these lines into ChatGPT and then ask it to explain to me why it was that particular one. Second one, what is the IP address of the attacker who performed the SQL injection attack? Okay, this is also going to be annoying too because I can't copy and paste. Okay, let's go back to that one. Which one was it? This one, line 147. And it's this thing. Right? Yes, I believe. Okay. Here's my really old school way of doing things. Now I cannot copy and paste. I'm using my cell phone to take a photo so I can manually look at it and enter it at the same time. So ghetto. Okay. 192.168.31.200. Whoops. Let's see. Why is that the wrong answer? Well, would it be the first one? I thought that was the... Oh, yes. Yeah, maybe that is. Sorry. So it's the first one above it because that is the one that's requesting. Yeah, that's the... Oops. What did we say? Line 1... Yeah, 14. 147, line 147. So this is the respond. This is the request. So the attacker is requesting it. So that's why it's this one. Okay, makes sense. Next one, next question. Was the SQL injection attack successful? Yes or no? Okay. And then what is the type of SQL injection attack? Classic, blind, or out of band? I would say this is classic. But let's see. Okay, was it successful? Let's see. How would I look for that? Well, it keeps giving them 200s. So I would say yes, it was successful. Yeah, like not once did it get denied. Like no 400 status code comes up, except for this one. But this is so short. I don't know. Well, like, what is this? It's not doing anything, I think. That's why. I think so. I think it was successful. There is a 404 here. 404 here, 404 here. What are they doing? Let's see. Get. This is just hard to scroll. That's why I'm not scrolling, but let me do that now. Okay, get this website, JS, add event listeners.js. Okay, 404. Okay, so it's trying to call this either web page or something up, and it's not responding because it doesn't actually exist. I tried a couple of times. Okay, so I'm gonna bet. Let me just take a look at the rest. It's like a lot of four. Like the pattern is 404, 200, 404, 200. And it's just trying to get the same thing. It's still this thing. It's still getting 404. 207 entries. So basically at line 147 and then 50 entries later, I guess they capped off. Let's see. Man, I wish I could expand this out a lot more so that I don't have a second line for one entry. So it's all just like, you know, one single entry on one line. That would be a lot easier to view. But unfortunately, cannot do that. Not on this screen. So I'm going to say yes. And let's see what they say. It's correct. And I also think it's classic. It wouldn't be blind because, you know, it's getting a response back. That's how the attacker is able to keep like going, keep like injecting different things to see what happens. And it's also not out of band because the out of band means that it's the kind of response is coming back in a different format. So that's why I'm assuming that is classic. And I was right. Okay, cool. Whew, well, that was long. Okay, so I took a look at the last 4 lessons. They're all very long with labs. And so I'm going to end the video here and then I'm going to start another one for part 2 of this particular course. So thanks so much for watching. If you enjoyed this one, remember to check out my next video for more hands-on cybersecurity. Let me know your thoughts and questions in the comments below. I'd love to hear from you. And always stay curious. See you in the next video.